Okay, students. So we completed the lesson. You all know what bonding is and why atoms form bonds. Then we discussed the two types of bonds, and you know about the properties of ionic and covalent compounds, as well as the way of denoting covalent compounds using different structures, that is the dot cross structure, Lewis dot diagram, and the Lewis structure. And thereafter we also discussed the atomic lattices, carbon, diamond and graphite, as well as we have discussed the intermolecular bonds as well as polarity of bonds. And then we discuss questions from your textbook. So as I told you all, I am going to discuss some extra questions as well. So extra question 1. Hydrogen is a non-polar molecule. Explain this briefly. How will you all explain a hydrogen molecule being a non-polar molecule? Hydrogen is H2 gas. So there are two hydrogen atoms are bonded by a covalent bond, and the electronegativity of the two hydrogen atoms are similar or same. So because of that, there is no polarity. The electrons are distributed uniformly or symmetrically between the two atoms of the bond. So it's a non-polar covalent bond. That is what you have to write here. In a hydrogen molecule, the two hydrogen atoms have the same electronegativity. Therefore, electrons of the covalent bond are distributed symmetrically. Thus, forming a non-polar covalent bond. Is that okay, students? In a hydrogen molecule, the two hydrogen atoms have the same electronegativity. Therefore, electrons of the covalent bond are distributed symmetrically, thus forming a non-polar covalent bond. Is that okay? So then the next question. Hydrogen fluoride is a polar compound. Explain this briefly. So here you know in hydrogen fluoride, that is HF. That is the compound. Hydrogen has less electronegativity. Fluorine has very high electronegativity. Because of that, the fluorine atom will draw the electrons towards itself. Therefore, there will be a partial negative charge on fluorine as well as a partial positive charge on hydrogen. That will give rise to the polar covalent bond, and therefore the compound becomes a polar compound. So that is what you have to explain here. So here we can say hydrogen atom has less electronegativity fluorine atom has high electronegativity. So here, because of the electronegativity difference between the atoms, fluorine attracts the bond pair electrons towards itself. Therefore, a partial negative charge forms on fluorine and a partial positive charge forms on hydrogen, giving rise to a polar covalent bond. Thus, the hydrogen fluoride is a polar compound. So, HF is the hydrogen fluoride molecule. Hydrogen atom has less electronegativity. Fluorine atom has high electronegativity. Because of the electronegativity difference between the atoms, fluorine attracts the bond pair electrons towards itself. Therefore, a partial negative charge forms on fluorine and a partial positive charge forms on hydrogen, giving rise to a polar covalent bond. Thus, the hydrogen fluoride is a polar compound. Is that clear to you all students? So, that is what you have to explain when you are asked to explain why hydrogen fluoride HF is a polar molecule or polar compound. With that, I will move on to the next question. Extra question 2. The first one there, what are intermolecular bonds? So, from the name you all know what intermolecular bonds are. The attraction or the force between the molecules is known as an intermolecular bond. So, here we can say the attraction between molecules is known as intermolecular bonds, or you can call it as intermolecular forces. Then the second one, use a diagram to illustrate the intermolecular bond present between molecules of water. So there, you know that water is a polar covalent compound. So it's a polar molecule. And there is attraction between the delta positive charge of hydrogen and delta negative of oxygen. That is what you have to show here. So when we have one water molecule like that, delta positive, delta negative and delta positive. There will be another water molecule, delta positive, delta negative and delta positive. So this will be the attraction. And that is the intermolecular bond between positive of one molecule and the partial negative charge of the second molecule. You all can see all are delta positive and delta negative. They are partial charges. So between those there is the intermolecular bond. I am sure you also drew the correct diagram. Then the third part. Write 4 special properties of water. So here you can see special properties of water due to its intermolecular bond. So what are the special properties? You all know those. They exist as liquid at room temperature. They have a high boiling point. Then they have differential expansion in freezing. That is, the density of ice is less than the density of water. And also they have high specific heat capacity. Those are the properties that you have to write here. So then you can say it is a liquid at room temperature. So that is one property. Then the second one we can say has high boiling point. Third one we can say has high specific heat capacity. And the fourth one, density of ice is less than the density of water. Or you can say has differential expansion in freezing. Either way is fine. So those are the 4 properties. It is a liquid at room temperature, has high boiling point, has high specific heat capacity, and the density of ice is less than the density of water, or you can say has differential expansion in freezing. I am sure you were able to write all those answers. With that, I will move on to the next question, extra question 3. Write the properties of ionic compounds. So you all are familiar with the properties of ionic compounds. What are ionic compounds? The electrostatic attraction between the positive and negatively charged ions. So the first property is that ionic compounds are made up of cations and anions, or you can say positive ions and negative ions. So that is the first property. They are made up of cations and anions, or you can say positive ions and negative ions. So because of this, how do they exist in nature? They are crystalline ionic lattices. So we can say they exist as crystalline ionic lattices. So because of that, they are crystalline solids at room temperature. They are crystalline solids at room temperature. What are the other physical properties, students? Because of the ionic lattice, they have very high melting and boiling point. They have high melting point and high boiling point. Can they conduct electricity in the solid state? No, but they can conduct electricity in the fused or molten state and the aqueous state. So that is another property. They cannot conduct electricity in the solid state, but they conduct electricity in the molten, or you can say fused state and aqueous state. What else can you say? Do they dissolve in water? Yes. So most of the ionic compounds dissolve well in water. Most of the ionic compounds dissolve well in water. So those are the properties that you have to write, students. So here they have said, write the properties of ionic compounds. So the first one, they are made up of cations and anions, or you can say positive ions and negative ions. So because of that, they exist as crystalline ionic lattices. And because of that, they are crystalline solids at room temperature. Then if you look at the other properties, they have high melting point and high boiling point. They cannot conduct electricity in the solid state, but they conduct electricity in the molten or fused state as well as the aqueous state, that is the solution. And also, most of the ionic compounds dissolve well in water. So here, students, I have included all the terms. Now, for example, you can just say either molten or fused. You don't have to write both the terms, or even simply you can say the liquid state. That is also fine. But in this answer, all the terms have been included as much as possible. So I am sure you were also able to write all these properties clearly. With that, I will move on to the next question. Extra question 4. How is a covalent bond formed? So you all know from the name covalent, sharing of valency. That is, they share their valence electrons. So by sharing electrons between a pair of atoms, covalent bonds are formed. So you can say covalent bonds are formed by sharing of electrons between a pair of atoms. So students, this is a simple explanation. Covalent bonds are formed by the sharing of electrons between a pair of atoms. So always when a covalent bond forms, there are two atoms involved. So that is why we say pair of atoms. Then the second question. Write three properties of covalent compounds. Here you need to write only three properties of covalent compounds. What are the properties? You can remember that. Unlike ionic compounds, covalent compounds exist as molecules of several atoms. It can be two or more atoms. Then they usually exist as liquids or gases at room temperature. They don't conduct electricity except for graphite, you all know, because of its atomic lattice structure. And some of the covalent compounds are soluble in water. And also usually they have low melting and boiling points. Again, there is the exception. Both diamond and graphite have very high melting point and boiling point because of their atomic lattice structures. So you can write any three properties for covalent compounds. So I can say they usually exist as liquids or gases at room temperature. Then the next point, they have comparatively low melting and boiling points. If you like, you can say except diamond and graphite because of their atomic lattice structure. Then what is the third point? You can write any one of the properties. I will say some of them are soluble in water. Some covalent compounds dissolve well in water. I am sure you know examples as well. What are the covalent compounds? Like glucose, sugar, these are covalent compounds that dissolve very well in water. So those are three properties of covalent compounds. They usually exist as liquids or gases at room temperature. Then they have comparatively low melting and boiling points. Again, I have included the exception except diamond and graphite. That is because of their atomic lattice. And some covalent compounds dissolve well in water. So those are the properties. I am sure you were also able to write it correctly. With that, we will move on to the next question. Extra question 5. How do ionic compounds form? So you all know how ionic compounds are formed. One atom loses its valence electrons and forms the positively charged ion or the cation, whereas those electrons are taken up by the more electronegative atom and that becomes the negatively charged anion. And the electrostatic attraction between the cation and the anion is the ionic bond. So here we need to explain how ionic compounds form. So we can say the less electronegative atom loses its valence electrons and forms the positively charged cation. These electrons, electron or electrons, are taken up by the more electronegative atom, forming the negatively charged anion. The electrostatic attraction between the positive and negative ions is the ionic bond that leads to the formation of an ionic lattice. So here I have included all the relevant points. So how do ionic compounds form? The less electronegative atom loses its valence electrons and forms the positively charged cation. So here again students, you all know, depending on the valency. For example, if it is sodium chloride, one sodium atom, one chlorine atom. They form the sodium ion and chloride ion. But if it was magnesium chloride, then you know there will be one magnesium ion and then two chloride ions. Or else if it is lithium oxide, then you know there has to be two lithium ions and one oxide ion. So that depends on the valency. I have not emphasized on that whether it's one or more than one positive ions and negative ions, but you all have to remember that it can depend on the valency. So then these electrons are taken up by the more electronegative atom, forming the negatively charged anion. And the electrostatic attraction between the positive and negative ions is the ionic bond that leads to the formation of an ionic lattice. So that is how ionic compounds form. Is that clear to you all students? So with that, I will move on to the next question. Extra question 6. Diagrammatically represent the ionic bond present in sodium chloride between sodium ions and chloride ions. So here they want you to represent the ionic bond. You don't have to show how the ions are formed. You only need to show the ionic bond present there. So to do that, if you remember the electronic configurations, then you can directly do it, students. Otherwise, you can start from scratch. You know the atomic number of the elements, then you know to write the electronic configuration, and from there you can write the ions. So sodium, you can remember 11, so it's 2, 8, 1. So how does the sodium ion form? By losing this one valence electron. So this is 2, 8. The same way, if you take chlorine atom, 17, 2, 8, 7. That will take up 1 electron and form the chloride ion. So, that will have 2, 8, 8 electrons. Is that okay? So, then you have to represent them diagrammatically. To do that, this is the nucleus of sodium, the first energy level, second energy level. I will use a different color to denote the electrons. In the first energy level, there are 2 electrons. In the second one, there are 8 electrons. So, we have to show all 8 electrons present in the valence shell. That is the sodium ion. What do? You have to draw square brackets and show the positive charge at the top right hand corner of the ion. Sodium, that is positive. The same way, the nucleus, the first energy level, second energy level, here there is a third energy level. And then we need to denote the electrons. In the first energy level, there are 2 electrons. In the second one, there are 8. 8 electrons in the second energy level and 8 electrons in the third energy level. So, we have completed all the energy levels. Then what do? You need to show the charge using square brackets, and here it is a negative charge. So, this is the sodium ion, positive ion or cation, and this is the chloride ion, negative ion or anion. The electrostatic attraction between the 2 ions, positive and negative ions. That is the ionic bond present in sodium chloride. So, did you all write it correctly? I am sure you did. So, with that, I will move on to the next question. Extra question 7. Explain the nature of the atomic lattice of graphite. So, you all know how graphite lattice forms. One carbon forms covalent bonds with 3 other carbons, forming hexagonal shaped molecules which form the carbon sheets. And these carbon sheets are superimposed layers. And between those carbon layers, there is a weak interaction that leads to the lattice structure. That is what you have to explain here. So, we can say one carbon atom bonds covalently with 3 other carbon atoms, forming the sheets of, or you can say layers of carbon. There is a weak attraction between these superimposed layers of carbon that can slide one over the other. This is the structure of graphite lattice. So these are the points that you need to include, students. So you have to say one carbon atom bonds covalently with 3 other carbon atoms, forming the sheets of carbon or layers of carbon, and there is a weak attraction between these superimposed layers. You remember that term, superimposed layers of carbon that can slide one over the other. That is again another property. Because of the weak attraction, they can slide one over the other. And this is the structure of graphite lattice. Is that okay, students? So then we will look at the next question. How are carbon atoms combined in an atomic lattice of diamond? So here you need to explain only the combination of carbon atoms. How are they combined? One carbon forms covalent bonds with 4 other carbons. So here you can say one carbon atom bonds covalently with 4 other carbon atoms, forming a 3-dimensional lattice. So here if we write that, that is enough. Because how are carbon atoms combined in an atomic lattice of diamond? That is the question. So one carbon atom bonds covalently with 4 other carbon atoms, forming a 3-dimensional lattice. So that is the answer. With that, I will move on to the next question, that is extra question 8. Complete the following table regarding chlorine atom and chloride ion. So you all know when chlorine atom gains an electron, it forms a chloride ion. So we have to fill the table. Here we have chlorine atom and here we have the Cl- ion, chloride ion. And the atomic number is given to you 17. So what is the number of protons? If you take chlorine atom, it's same as the atomic number, so 17. So how many? The number of positive charges, that is 17 positive charges. Number of electrons, that is again 17. So number of negative charges also 17. So what about the total charge? You have 17 positive charges and 17 negative charges. So the total charge is 0. But if we take the chloride ion, atomic number is the same, 17. So the number of protons is the same, 17. And number of positive charges again the same number, plus 17 positive charges. Number of electrons is 18. Why? The chlorine atom takes up 1 electron and forms the chloride ion. So number of electrons 18. Number of negative charges, that is also minus 18. So what is the total charge? Plus 17 minus 18. So there is a negative charge. 1 negative charge, minus 1. So that is why a chloride ion has a negative charge. Is that okay, students? So I am sure you were able to fill this table correctly. With that, I will move on to the next question, extra question 9. What are ions? You have to say ions are an atom or a group of atoms with an electrical charge. That is what we have to write here. So ions or ions are atoms or a group of atoms with an electrical charge. So that is an ion or ions. Ions are atoms or a group of atoms with an electrical charge. Then the second question. Illustrate the formation of sodium ions and chloride ions with equations. So here we need to use equations to illustrate the formation of sodium ions and chloride ions. What happens? Sodium atom is there. Sodium atom loses an electron and forms the Na plus, that is sodium ion, and there is an electron lost. And that is taken up by the chlorine atom. So here chlorine atom plus electron gives rise to chloride ion. Is that okay, students? So sodium loses an electron, forms a positively charged sodium ion or a cation, whereas chlorine takes up the electron and forms the Cl minus ion. So always remember, students, we normally don't show the negative electron. We don't put a sodium minus electron. We have to write it on the other side as plus electron. Is that clear to you all? So illustrate the formation of sodium ions and chloride ions with equations. These are the equations. With that, I will move on to the next question. Extra question 10. And the first one is, what is a Lewis structure? You all know what a Lewis structure is. What is it? For a covalent molecule, when you use a short line to denote the bond pair electrons and dots to denote the non-bonding lone pair electrons, we call it a Lewis structure. So here we can say, when a bond pair electrons are shown by a short line and the non-bonding lone pair electrons are shown by dots in a covalent molecule. It is known as Lewis structure. So that is the explanation for Lewis structure. When a bond pair electrons are shown by a short line, that you all know, and the non-bonding lone pair electrons are shown by dots in a covalent molecule, it is known as Lewis structure. And you all know how to draw Lewis structures. And also, students, you can remember, in this we only consider the valence electrons. So the valence electrons are the electrons that become the bond pair electrons as well as the lone pair electrons. So then the second question, draw the Lewis structure of ammonia. So you know ammonia is NH3. How do we draw the Lewis structure? We have to first write the central atom, nitrogen. Then there are 3 hydrogens because it's NH3. And then we need to show the bonds. So this is a Lewis structure. So the bond is shown by a short line like this. And does that satisfy the octet for nitrogen? No, because 1, 2, 3, there are only 3 bonds, 3 pairs of electrons, so that's 6. But you all know nitrogen normally has 5 electrons in the valence shell. After forming 3 bonds, it has to have 8 electrons. So there is 1 lone pair. We show that here, the lone pair electron. So that is the Lewis structure of ammonia. Is that okay, students? So then we will move on to the next question, where we draw the Lewis structure of methane. What is the chemical formula of methane? CH4. So from the formula you know carbon is the central atom and there are 4 hydrogen atoms. We have to distribute them around carbon, and then in a CH4 molecule there are 4 CH bonds. So those have to be denoted by short lines like that. And that satisfies the 8 electrons because there are 4 bonds, 4 pairs, that is 8 electrons. And for hydrogens, there are 2 electrons each. So that means all these atoms have a complete valence shell after they form the bond or after they form the covalent compound. Is that okay, students? So then the Lewis structure of methane. So here we have explained what Lewis structure is. So in a Lewis structure we use short lines to denote the bond pair electrons and dots to denote the lone pair electrons. And in an ammonia molecule there are 3 NH bonds. So there are 3 bond pair electrons, the 3 lines, and 1 lone pair electrons on nitrogen. So those are the 2 dots. But for a methane molecule there are 4 bond pair electrons. So we use 4 lines to show those 4 bond pair electrons. I am sure you also wrote these structures correctly. With that, I will move on to the next question. Extra question 11. Draw the dot cross diagrams for the molecules given below. So all you have to draw is dot cross diagrams. First one is chlorine. So here there should be 2 chlorine atoms, and to denote the bond we use a dot and a cross. So dot and cross, and there are 3 lone pairs on chlorine. You are familiar with that. So 3 lone pairs, 3 pairs of dots for this chlorine and 3 pairs of crosses for the second chlorine. You can always confirm by counting the number of electrons. 2, 4, 6, 8. So 8 electrons around this chlorine, 2, 4, 6, 8 around the second chlorine. So that is the Cl2 molecule. Then we have N2. So 2 nitrogen atoms. And here you can remember, students, valency of nitrogen is 3. So it has to form 3 covalent bonds. They have to share 6 electrons. So there should be 6 dot cross dot cross dot cross. So 3 bonds. It's a triple bond. And you know there is a lone pair on each nitrogen. So 1, 2, 3, 4 pairs. So 8 electrons around this nitrogen and 1, 2, 3, 4 pairs of electrons. That's 8 electrons around the second nitrogen. So 3 bonds, a triple bond, and 1 lone pair on each nitrogen atom. That is the dot cross diagram for N2 molecule. Then for O2 molecule, again oxygen, oxygen. And what is the valency of oxygen? 2. So it forms a double bond. So 2 bond pairs of electrons. So there should be 4 electrons. So dot cross 1 bond, another dot and cross the second bond. So that's the double bond. But you all can remember, students, there are 6 electrons on oxygen, the valence shell of oxygen. So there should be another 4 electrons. They exist as 2 lone pairs. So here the 2 lone pairs. And here crosses for the 2 lone pairs. So now you can see again 1 pair, 2, 3, 4 pairs of electrons or 8 electrons around this oxygen. Again 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons around the second oxygen. So again the octet is satisfied. Then if we take hydrogen molecule, a very simple molecule, 2 hydrogen atoms, and in hydrogen atoms there's only 1 electron. So each atom gives 1 electron forming 1 single bond. So that is a dot and a cross. A very simple molecule. And their valence shell is also complete. So these are the dot cross diagrams for the molecules chlorine, oxygen, nitrogen and hydrogen. Is that okay, students? So with that, I will move on to the next one, extra question 12. Draw the Lewis dot diagram for chlorine gas. Lewis dot diagram. So we already drew the dot cross diagram. You all know it is Cl2. So 2 chlorine atoms. Here we have to draw Lewis dot diagram. So to show the bond, we use only dots. Both the chlorines contribute 1 electron each, forming a single bond. But because they have 7 electrons in the valence shell, they have 3 lone pairs. 1, 2 and 3 lone pairs. The same goes for the second chlorine. 3 lone pairs. So again, if you want, you can count and confirm that there are 8 electrons. 2, 4, 6, 8, 2, 4, 6, 8. 8 electrons around both the chlorine atoms. Then the next one. Draw the Lewis dot diagram of methane gas. Again, methane gas. So, carbon in the middle, 4 hydrogens. And again, we have to draw the Lewis dot diagram. So, all are single bonds. A pair of dots for the bond pair electrons. And a single bond between these. All the CH bonds are single bonds. Each hydrogen has 2 electrons in its valence shell, so that's complete. And carbon gets 4 electrons in its valence shell. 2, 4, 6, 8. So that is also complete. So that is the Lewis dot diagram of methane gas. With that, I will move on to the next question. Extra question 13. What are atomic lattices? What are they? Lattices in which atoms are covalently bonded. Those are the atomic lattices. So you can say lattice structures in which atoms are covalently bonded. So that is the important point. You have to say the constituent particles are atoms and they are covalently bonded. And that leads to the formation of a lattice structure. So that is an atomic lattice. The second question. Write an element that exists as atomic lattice in nature. Can you all think of the element? What is it? It's carbon. So that is what we have to write here, carbon. So you can say carbon or you can write the symbol C, capital C. Then the next question. What is the hardest substance found naturally on Earth? What is the reason for its hardness? So what is the hardest substance? That is diamond. And what is the reason? In a diamond that also exists as an atomic lattice, one carbon atom is bonded with 4 other carbon atoms covalently, forming a 3-dimensional lattice. And due to the strength of all the covalent bonds, the hardness of diamond is high. So that is what you have to write here. What is the hardest substance? Diamond. And what is the reason? Diamond is an atomic lattice in which one carbon atom is can say covalently bonded to 4 other carbon atoms forming a 3-dimensional lattice. So students, they have asked what is the hardest substance found naturally on earth and what is the reason for its hardness. You all know the hardest substance is diamond, and the reason is that diamond is an atomic lattice in which one carbon is covalently bonded to 4 other carbon atoms, forming a 3-dimensional lattice. That is why it has a very high hardness. So I am sure you were also able to write a similar explanation. With that, I will move on to the next question. Extra question 14. Water is made up water molecules. How does a water molecule form? How does a water molecule form? Oxygen shares 2 electrons with 2 hydrogen atoms forming 2 OH covalent bonds, and that is the formation of a water molecule. So here we can say one oxygen atom shares 2 electrons with 2 hydrogen atoms and forms 2 OH single bonds. That is the formation of water molecule H2O. So, is that clear, students? One oxygen atom shares 2 electrons with 2 hydrogen atoms and forms 2 OH single bonds. That is the formation of water molecule H2O. So, there are 2 single bonds, but oxygen gives 2 electrons, hydrogens give 1 electron each. So, that's how water molecule is formed. Then the second question. Hydrogen chloride gas is made of hydrogen chloride molecules. How does a HCl molecule form? So, how does an HCl molecule form? By the sharing of a pair of electrons between hydrogen atom and chlorine atom. So, here we can say hydrogen atom and chlorine atom form a covalent bond by sharing a pair of electrons between them. So that becomes the hydrogen chlorine single bond or the covalent bond. So here students, the question is hydrogen chloride gas is made of hydrogen chloride molecules. How does a hydrogen chloride molecule form? So hydrogen and chlorine atom form a covalent bond by sharing a pair of electrons between them, and that is the HCl molecule. So that is what you have to write here, students. So if you want, you can draw the Lewis structure and show the molecule as well. So here you can otherwise just leave it with the explanation. That is also fine, because they have asked how does a hydrogen chloride molecule form. That is what you have to explain. So with that, I will move on to the next question. Extra question 50. What type of elements form ionic compounds? What type of element form ionic compounds? An element that has a low electronegativity when combining with an element that has a very high electronegativity, then they form ionic compounds. So you can say when a compound is formed between an element with less electronegativity and an element with high electronegativity. Or in other words, what can you say? When a bond is formed between elements with a significant electronegativity difference. So here you can see, or when a compound is formed between elements with a significant or we can say high electronegativity difference. So that is when ionic compounds are formed. What type of elements form ionic compounds? When a compound is formed between an element with less electronegativity and an element with high electronegativity. Or you can see when a compound is formed between elements with a significant electronegativity difference, it becomes an ionic compound. Is that clear to you all, students? So you all know if it is between sodium and chlorine. Sodium is less electronegative, chlorine is highly electronegative. So because of that, sodium loses electrons and chlorine gains the electron. That's an ionic compound. But you all know, students, if it is between hydrogen and chlorine, hydrogen is less electronegative but not less like sodium. So HCl is a covalent molecule where they share electrons, but it becomes a polar covalent compound. I have explained this to you all in the lesson as well. If the electronegativity difference is very high, that's what I have said, significant, then it becomes an ionic compound. But if it is somewhat less, then it forms a polar covalent bond. And if the electronegativities are similar or same, then it will be a non-polar covalent bond. Is that clear to you all, students? So with that, I will move on to the next question. Extra question 16. What is electronegativity? What we discussed before, but we didn't discuss the definition. What is it? Ability of an atom of an element to attract electrons from a bond is known as its electronegativity. So that is what you have to write here. Ability of an atom involved in a bond to attract the electrons towards itself is known as electronegativity. Is that okay, students? I'm sure you also wrote the same explanation. Ability of an atom involved in a bond to attract the electrons towards itself is known as electronegativity. Then the second question. Potassium fluoride is an ionic compound. Explain the ionic bond formation based on electronegativity of the elements. So here you need to explain. So what do you know? Potassium chloride. In this you all know K is the positive ion and F is the negative ion. So what can you all say? Potassium is very less electronegative. Therefore, it can easily lose an electron and form the K plus cation. Whereas fluorine is highly electronegative. Therefore, it easily takes up electrons and forms the negative ion. And the attraction, electrostatic attraction between K plus and F minus leads to the formation of the ionic bond. So that is what we have to explain here. So we can say potassium is less electronegative. Therefore, it can easily lose the valence electron and form the K plus cation. Fluorine is highly electronegative. Therefore, it has the tendency to take up electrons and form the F minus anion. The electrostatic attraction between the K plus ion and F minus ion is the ionic bond. So for this question, students, the main thing that you need to explain is how potassium becomes the cation and fluorine becomes the anion, because they have said potassium fluoride is an ionic compound. Explain the ionic bond formation based on the electronegativity of the elements. So here you can see potassium is less electronegative. Therefore, it can easily lose the valence electron and form the K plus cation. Fluorine is highly electronegative. Therefore, it has the tendency to take up electrons and form the F minus ion, that is the fluoride anion. The electrostatic attraction between the K plus ion and the F minus ion is the ionic bond. So, the first part gives you the explanation related to electronegativity. I have written the last sentence in order to complete the answer. I am sure you were also able to explain this in this manner. So with that, I will move on to the next question. Extra question 17. The following activity was carried out by a group of students to observe a property of solutions of glucose and sodium chloride. So if you look at this activity, students, you are familiar with that. We have done this in the lab as well. So you all know here there is the solution inside a beaker and there are two electrodes that is connected to the circuit, and there you can see the battery here. So current is supplied. There is a switch to on and off the circuit and also a bulb. So from this, what are they trying to observe? They are trying to see whether the solution conducts electricity. So what are the solutions that are used? Glucose and sodium chloride. So you are familiar with this activity as well. Okay, we'll look at the questions. Write the observations of the activity. What are the observations? It's either the bulb will light or the bulb will not light. So when you use a solution of glucose, what happens? Bulb does not light. So, glucose solution bulb does not light. And when we use sodium chloride solution, bulb lights. So those are the observations. When you use glucose solution, the bulb does not light, and when you use sodium chloride solution, the bulb lights. So then the next question. Explain the observation based on bonding. So how can you explain that? Here you know glucose is a covalent compound. Although it dissolves in water, covalent compounds do not conduct electricity. But sodium chloride is an ionic compound and they conduct electricity in the solution state or fused state. So here it is the solution state. That is what you have to explain here. Explain the observation based on bonding. So we can say glucose is a covalent compound they do not conduct electricity in the solution state. You don't even have to say solution state because they don't conduct electricity. But sodium chloride is an ionic compound. They conduct electricity in the solution state. So here you have to explain the observation. Therefore, bulb does not light when glucose solution is used in the beaker. But it lights when sodium chloride solution is used. Solution is used. So that is the explanation. Because glucose is a covalent compound, they don't conduct electricity in the solution state. So when that is used, the bulb does not light. But when you use the sodium chloride solution, since it's an ionic compound, it conducts electricity and the bulb lights. So that is how you answer this question. With that, I will move on to the next one. Extra question 18. Following diagram show the structures of A and B atoms. So when you look at the structure, students, it's better if you can identify the elements. So look at the first atom, A. You can write down the electronic configuration. First energy level has 2 electrons, second one has 8 electrons, and the third energy level has 2 electrons. So it's 282, atomic number 12. That means it is magnesium. The same way, if you look at element B or the atom of element B, what is it? There are 2 electrons in the first shell and you can see 6 electrons in the second shell. Atomic number 8. What is that element? It's oxygen. So we have identified the 2 atoms. But when you are answering the question, students, you have to use the letters given to you. Sometimes they say that in the question, use the given symbols to answer the questions. If not also, it's better you use those symbols or the letters given to you. What is the element with the highest electronegativity? Out of the 2, what is the element with highest electronegativity? It's oxygen. So you have to say element B. Then the next one. What is the type of bond formed between A and B? You know magnesium is a metal. Usually they are very less electronegative and they form cations easily. Whereas oxygen is electronegative, so it prefers to form the anion. So what type of bond will be formed? It will be an ionic bond. So you can say ionic bond. Then the last question. Write the chemical formula of the compound formed by A and B. So you know when magnesium loses electrons, it will form Mg2+, whereas oxygen will form O2-. So it will be A2+ and B2-. So here the charges are the same. So you will have the chemical formula as AB. If you write it the way you normally write the chemical formula, you all know, students, it is the empirical formula, the simplest ratio between the ions that are present in the compound. So here we have answered all the questions. Out of these, element B has the highest electronegativity because one is very less electronegative and the other one is highly electronegative. They form ionic bonds and also the chemical formula is AB. So I am sure you were able to write all the answers. With that, I will move on to the next question. Extra question 19. Structures of 4 substances are given below. write the letter or letters corresponding to each of the following. So here the questions are given. You have to write the relevant letter corresponding to these properties. So then, if you look at P, can you identify what that is? That is the atomic lattice of diamond. So I will just write that down here. P is diamond. Then it is easy for us to identify and answer the questions. Q, what is Q? Here you can see the red color dots and the green color dots. They correspond to different ions. So you can remember we have discussed the ionic lattice of sodium chloride. So sodium ions are red and the chloride ions are green. So that is sodium chloride, NaCl. And what is this? You can see this red color with the two white color atoms. What does that resemble? Those are water molecules. So this is water, H2O. And what is this? By looking at the lattice itself, you know it is graphite. So this again is for our reference. Then it's easy to answer the questions there. So the first one, compound that exist as simple molecules in nature. Out of these three, what is the simple molecule? It's R. Allotropes of an element. What are the allotropes? Diamond and graphite. So it's P and S. The compound with highest boiling point. What do you think, students? There is diamond, graphite and sodium chloride. So sodium chloride is an ionic compound, whereas diamond, graphite, they are covalent compounds. So out of those, here you can see the compound with highest boiling point. So diamond and graphite are not compounds, they are elements. So what is the compound? That is sodium chloride, and that has a higher boiling point than water. So it has to be Q. Then the fourth one, the compound that conduct electricity in the fused state but not in the solid state. What is that? Those are the ionic compounds. So it has to be sodium chloride, Q. Then two compounds which are most likely to form a solution when mixed. Now here out of these, water is the only solvent. That is the one that can dissolve substances. Diamond doesn't dissolve. Sodium chloride, it dissolves. Graphite does not dissolve. So salt and water, they mix well and form a solution. So that is Q and R. So is it okay, students? The compound that exists as simple molecules in nature, that's water, R. Then allotropes of an element, diamond and graphite, that is P and S. The compound with the highest boiling point, again Q, sodium chloride. Compound that conduct electricity in the fused state but not in the solid state, again ionic compound, sodium chloride. And two compounds which are most likely to form a solution when mixed, sodium chloride and water, Q and R. With that, I will move on to the next set of questions. There are 5 more. The compound which exists as liquid at room temperature. Already we have identified R is water. So R. Then substance that conducts electricity in the solid state. Out of these, diamond never conducts electricity. Q, sodium chloride, that will conduct electricity only in the liquid state or the solution state. Water, pure water, doesn't conduct electricity. Why? It's a covalent compound. But S, atomic lattice, that is graphite, because it has free electrons, it can conduct electricity well. So substance that conducts electricity in the solid state is S. And naturally existing harder substance. So out of these, you all know, students, diamond is a naturally existing allotrope of carbon and that is the hardest substance. So that is P. And substance with intermolecular bonds. Out of these, only R, water, has intermolecular bonds, R. Because here it is only the covalent bond. In Q, there is the ionic bond. In water, there are covalent bonds, that is within the molecule, and between the molecules, that is intermolecular bond is present. Again in graphite, it is only the covalent bonds. And the last one, example of ionic lattice, that is again Q, that we have already identified. So I am sure you were also able to write all the letters. The compound which exists as liquid at room temperature, water R, substance that conducts electricity in the solid state, graphite, that is S, naturally existing harder substance, that is diamond, P, substance with intermolecular bonds, again water R, and example of an ionic lattice, that is sodium chloride. So all those are the answers. With that, I will move on to the next question. This is the last question. Extra question 20. Aluminium chloride and phosphorus pentachloride. So, aluminium chloride and phosphorus pentachloride are stable compounds that you know they are present in nature. But they do not satisfy the noble gas electronic configuration. Explain this using the Lewis structure of the molecules. So you have to draw the Lewis structure and explain the reason. So for that, if you all can remember, students, if you remember the Lewis structure, you can draw it directly. Aluminium chloride is AlCl3. AlCl3. So in this you can remember aluminium is the central atom. Around aluminium, the 3 chlorines are arranged like this. And there is a single bond between the aluminium and the chlorine atoms. And around chlorine atoms, if you can remember, there are 3 lone pairs. Why? Chlorine has 7 electrons in the valence shell. So you have to remember the Lewis structure, students. So in this, if you count the number of electrons around the chloride atoms, you can see 2, 4, 6 and bond pair 8. So that satisfies the octet rule. Same goes for this chlorine. 1, 2, 3, 4, 4 pairs, 8 electrons. 1, 2, 3, 4. So there are 4 pair of electrons. Therefore 8 electrons are there. So that also satisfies the octet rule. But if you take aluminium, the central atom, 1, 2, 3. There are only 3 bonds. So there are only 6 electrons around aluminium. It does not satisfy octet number less than 8, but still it is a stable molecule. So that is what you have to write here. So we can say in this, the chlorine atoms have 8 electrons in the valence shell after bonding. But the central atom has only 3 bond pair electrons. That is 6 electrons. It does not satisfy the octet configuration. But already they have mentioned that they are stable molecules. So you don't have to repeat that again. The same way you will have to explain for phosphorus pentachloride. Before I go to that, I will explain this again. So you can remember AlCl3, this is the Lewis structure. In this, the chlorine atoms have 8 electrons in the valence shell after bonding that we discussed. But the central atom has only 3 bond pair electrons, that is 6 electrons. It does not satisfy the octet configuration. But aluminium is stable and the molecule aluminium chloride is stable. So we have explained the observation. Then the next molecule, that is phosphorus pentachloride. You can remember PCl5. If we write the molecule, phosphorus is the central atom, Cl, Cl. There are 5 chlorine atoms. And if you remember, students, around each chlorine atom, there are 3 lone pairs around each chlorine. All the chlorines have 3 lone pairs. So here again, if you look at the structure, all the chlorines, those are the peripheral atoms, they have 8 electrons each. If you count 1, 2, 3, 4, so 4 pairs, that means 8 electrons. That is there for all 5 chlorines. But if we take the central atom phosphorus, 1, 2, 3, 4, 5 bonds, that means there are 10 electrons. 5 bonds, 5 pairs of electrons, 10 electrons. This is more than 8. So again, it does not satisfy the octet electronic configuration. That is what you have to write here. In this molecule, the peripheral atoms are chlorine atoms. They all have 8 electrons. But the central atom phosphorus has 5 bond pair electrons around it. Therefore, there are electrons that is more than the octet configuration. So after that, like a conclusion, we can say both aluminium chloride and phosphorus pentachloride do not satisfy the octet configuration, but they are stable compounds. So here you can see in this molecule, the peripheral atoms are chlorine atoms. They all have 8 electrons. But the central atom phosphorus has 5 bond pair electrons around it. Therefore, there are 10 electrons. That is more than the octet configuration. So, in both AlCl3, that's aluminium chloride, and PCl5, phosphorus pentachloride, do not satisfy the octet configuration, but they are stable compounds. That is what they are, stable compounds. So, here that is what we were supposed to explain. Is it clear to you all, students? Okay then. So with that, I have completed all the extra questions as well. So in this lesson, we discussed the bonding. That is how and why atoms form bonds. You all know, to satisfy the octet configuration or to attain the noble gas electronic configuration. To do that, they can either lose and gain electrons or form ionic compounds, or by sharing electrons they can form covalent compounds. Then under ionic compounds we discuss how ionic bonds are formed and then the ionic lattices and their properties. Thereafter, covalent compounds, we drew the molecules, then we looked at single bond, double bond and triple bond, as well as homoatomic molecules and heteroatomic molecules. Thereafter, we discussed the different ways of writing structures, Lewis dot cross diagram, Lewis dot diagram, and the Lewis structure for covalent molecules. And then we looked at the atomic lattice structures of diamond and graphite. Thereafter, the intermolecular bonds and also polarity of bonds. And finally, we discussed the properties of ionic compounds and covalent compounds. So with that, students, I am sure you have a very good understanding of the lesson, and then we discuss the questions from your textbook as well as the extra question. So when you keep on practicing, trying to answer questions, you will become more competent with the lesson.